In the previous lecture, we established that the speed or the velocity of an object measures how quickly an object moves. The units of the speed or the velocity, kilometer per hour or meters per second, shows the dependence of the speed on both distance, whose unit is kilometer or meter, and time, whose unit is hour or second. So as we are saying that it is distance per time or divided by time. We will now clarify motion based on weather. We will now classify motion based on whether the velocity is constant or variable. So the velocity might be constant or varied or variable. And based on this, we are going to classify motion into one, we call it uniform motion. Uniform motion. In uniform motion, when the velocity of a moving object is constant, so when we have a constant velocity, or where the body is moving with constant speed, as a car, for example, moving on a straight highway with a constant speed, say, for example, 100 kilometers per hour, then the car or the motion of this object is said to be uniform motion. So whenever the speed is constant, the motion is said to be uniform. One of the main objectives of mechanics is to investigate the relationship between displacement, velocity, and time, mainly between displacement and time, as this enables us to find the position corresponding or the position or the distance covered and also the speed of the moving object at different times. This is our main objective, to find the relation between displacement and time, the speed and time. Once we are able to know the displacement or the speed of a moving object at each time, we can describe how the motion of this body is said to be known completely. The equation that relates the distance covered to the time is referred to as equation of motion, which is very important. So we need to know the equation of motion in order of any moving object, in order to describe this motion. So equation of motion which relates x or displacement or position to the time. In case of the uniform motion, the equation of motion is x equal, which is very simple and very important, x equal v times t, where x again is the displacement or distance, and again we have to use the SI unit, where the SI unit of distance is meter. The speed, the v designates, or v is the speed or the velocity of the moving object, or the velocity, and where the SI unit is meter per second. Finally, t is the time, represents the time passed. The time. So now this is the rule. This is the time equation, the equation of motion to be used in case of uniform motion, where we mean the speed is constant, or the object is moving with a constant speed. Algebra tells us that if x is equal to v times t, this means that v is equal to, v is equal to x divided by t. And in case we need to find the time, t is equal to x divided by v. As simplification, you can use this triangle, for example, where we say x is equal to v times t. So if you need x, simply x equals v times t. If you need v, so v is equal to x divided by t. If you need t, then t is equal to x divided by v. So x is v times t, t is x divided by v, and v is x divided by t. Let's consider or solve some examples related to uniform motion. For example, let's take example 1, where a car travels at constant speed. So again, since the speed is constant, then the motion is said to be uniform, and we can use the time or the equation of motion, which is x equal vt, which represents the motion, the uniform motion. So the car travels at a constant speed of 100 kilometers per hour. What distance does it cover in 5 minutes? The first step to solve any problem, the first step to do is to write down the given, from in the problem. For example, here the speed. So I'm going to take the given, the speed, and the unit. So this unit indicates that this is the magnitude of the speed. So the speed is given to be 100 kilometers. And as we already know, that the speed is designated as v. So v is equal to 100 kilometers per hour. But again, as we know, it should be converted into the SI unit of speed, which is kilometer per second. And we have mentioned in previous lectures that to do this, we have to divide by 3.6 in order to convert into meter per second, which is equal to about 27.77 meters per second. So we have to convert it to meters per second. Let's continue to write down the given. What distance it is required to find the distance or displacement, which we designate usually by x. So it is required to find x. Does it cover in 5 minutes? 5 minutes indicates the time. So minutes is a unit of time. Then 5 minutes indicates that the time is given to be 5 minutes. Time, which is represented as t. So t is given to be 5 minutes. Again, we have to convert it into the SI unit of time, which is seconds, to multiply it by 60. So 5 times 60 is equal to 300 seconds in order to convert it into SI unit of time, which is the second. So again, so this is time equals 5 minutes times 60 in order to convert it into seconds. 300 seconds. This is the speed. Again, this indicates the speed. V designate the speed, x distance or displacement, and t time. So let's go back to the equation, which is x equal v times t, v equals x times t, and v equals x over t, sorry, and finally t equals x over v. We need x, so we have to use this equation. So since we need to find the displacement x, we need to use the first equation, which is the equation of motion of uniform motion. So x equals to v is equal to v times t, substituting the values, the given values. So it's just now to replace the symbols by the corresponding values or numbers. X is equal to v, which is 27.77 times the time, which is 300 seconds. This is equal to, you can use calculator to find that it is equal to 8,331 meters. So the distance covered by this car, which is moving with a constant speed, 100 kilometers per hour, this distance during 5 minutes, the distance covered during these 5 or within these 5 minutes is equivalent to 8,331 meters. Let's move to example 2. If a thunderstorm occurs at an altitude of 670 meters. So again, let's write the given directly. So now I'm going to find the given in the question. So altitude of 670 meters. This, if we don't know exactly what is meant by altitude, just the unit tells us that we are talking about distance. So meter indicates the distance. So it is given now that x is equal to, 670 meters. And the sound of the thunder is heard 2 seconds after. 2 seconds indicate the time. The second indicate the time. So here it is given that the time is 2 seconds. So t equals 2 seconds. After the lightning flash is observed, calculate the speed of the sound. It is required to find the speed of the sound. Calculate, which means that we need to find, it is required to find the speed of the sound. So the speed is given, the speed of the sound. We have to find the speed of the sound, or deduce the speed of the sound. So what we have now is a thunder at a certain place above the surface of the earth at distance 670 meters. And as you know, we usually see the lightning. When the thunder occurs, we usually see the lightning first, and after a short while, we hear the sound of the thunder. This is the time taken by sound to cover this distance. So the time taken here in this example, the time taken by the sound to cover this distance from the place of the thunderstorm to the earth surface is 2 seconds. So we can deduce the speed of the sound. Again, it is required to find v. Let's go back to the equations. To find v, we have to use this equation. V is equal to the displacement divided by time. So now let's write the solution, which is v is equal to x divided, or the displacement divided by the time. So both units are in SI units, so there's no need to make any conversions. So it is 670 divided by 2, which is equal to 335 meters per second. So the speed or the velocity of sound is about 335 meters per second. Let's move to the third and last example. A satellite transmitting TV signals is positioned at an altitude of 36,000 kilometers. So this is again the distance. This indicates the distance. Again, let's deduce or find the givens in the question. So 36,000 kilometers indicates the distance or the altitude. So x is equal to 36,000 kilometers, and let's change it into SI unit of the distance, which is meters. So we have to multiply, as we had mentioned in previous lecture, to multiply by 1,000, and then it is equivalent to 36 million meters. How long does it take? How long does it take means that is asking about the time. How long does it take? So it is required to find the time for the signal to reach Earth, knowing that the signal travels at the speed of light. So this is the speed of light, which is 300 million meters per second. So it is given that the speed of light is 300 millions per second. So V equal 300 millions, which is a very famous speed, millions meter per second. This is the speed of light. And sometimes it is designated as C, since it is a very famous constant in nature. Let us now call it V, as in the preceding examples. So now it is required to find the time. Again, let's go back to the equations of the uniform motion. Since we need t, so we have to use this equation. T is equal to the displacement or x divided by the speed. So simply t is equal to x divided by v by substituting the value of each of the givens. So this is x, which is 36 million meter, divided by the speed of light, which is 300 million meters per second. This is equivalent to, or use your calculator to find that this time is equal to 0.12 seconds. So now if the satellite, for example, this is Earth, let's say this is Earth, and the satellite is located here at distance 36,000 kilometers. So if we have at a certain region on Earth here, for example, a TV broadcasting station which sends the signal to the satellite in its turn will reflect it back to our home, to our TV here. So if it takes about 0.12 seconds for the signal to reach us, it approximately also takes about this 0.12 seconds for the signal to move from the station to the satellite. So in total, it takes the signal from the station to reach our TV so the total time will be about 0.12 up plus 0.12 down, 0.24 seconds. So it takes the signal to be sent from the TV station, broadcasting station, to our TV 0.24 seconds, which is a very small time that we feel as if it is live broadcasting.